Hello everyone, welcome back to Coders Project. In today's video, we're going to be solving the merge to sorted list problem on LeetCode. So this problem is super common in coding interviews, and mastering it will not only strengthen your linked list skills, but it will also help you think logically when you are solving the problems in an interview. So this problem is all about merging two linked lists into one sorted list. Think of it like you're trying to merge two playlists that are already sorted alphabetically or by date. So it's pretty straightforward once you understand the logic, but it's also easy to trip up if you don't catch the edge cases over here. So let's get into it. You're given the heads of two sorted linked lists, list one and two. We need to merge the two lists into one sorted list. The list should be made up by splicing together the nodes of the first two lists, and we need to return the head of the merged linked list. So our job is to combine them into a single sorted list. The catch over here is we need to do it directly by reusing the nodes from the original list. We cannot create new lists or mess up the order. We need to understand the building blocks of a linked list, the nodes. So in Python, we represent a node within a class. Each node has two parts, a value and a pointer to the next node. So over here, here's what's happening in this definition of a singly linked list. So the val is basically it's going to hold the value of our current node, and the next is a reference to the next node in the list. If there is no node, it just sets it to none. Pretty simple, right? Now let's take a look into our main function, what's been given. It's called merge to list, and it takes a head. It takes the heads of two linked lists as input, and it returns the head of the new merge list. So let's get into it now. So what we're going to be doing is we're going to assign a dummy node. Think of it like a placeholder, which will make it easier to manage the merge list without worrying about the edge cases like an empty list or adding the first node. So let's go ahead and create a dummy node. So dummy is equal to our list node, and current is equal to dummy. So dummy is just a starting point now. It doesn't hold any real value. The current pointer helps us build the merge list by pointing to the last node which we have added. Now getting to our solution, the main part of it, we're going to be traversing both the lists simultaneously, and we're going to compare the values at each step. The smaller value should get added to the merge list. So we're going to use a while loop for that. While list1 and list2, if list1 dot val is lesser than or equal to list2 dot val, current dot next is equal to list1, and list1 is equal to list1 dot next, else current dot next is equal to list2 dot, and list2 is equal to list2 dot next. Now we update our current. Current is going to be current dot next. So here's what's happening now. We loop as long as both the lists have nodes left in list 1 and list 2. At each step, we're comparing the values of the current nodes in list 1 and list 2. And if list 1 has smaller value, we attach it into a merge list and move on to the next node in list 1. Otherwise, we do the same for list 2. And finally, we move the current pointer to keep track of the last node in the merge list. Simple enough, right? So once we have added, once one of the list is empty, we just go ahead and attach the remaining nodes from the other list. We need to do this because both lists are already sorted, so the remaining nodes are guaranteed to be in the right order. So let's go ahead and do that now. Current dot next is equal to list 1 if list 1 or list 2. So if list 1 has nodes, we attach them. If not, we attach the nodes from list 2. No need for any more comparisons over here. And then we just return our dummy. dummy.next. All right, let's take a quick look at the performance over here. The time complexity is going to be O of n plus m, where n is n and m are lengths of these two lists, list 1 and list 2. We process each node exactly once, so the space complexity is going to be O of 1. Let's go ahead and run the test cases now. Looks like we're failing one of our edge cases. Let's take a look into the code. Okay, so we need to append the remaining nodes from the non-empty list outside our while loop. Uh, let's rerun this. All right, looks like the test cases have passed. Let's go ahead and run the other test cases. Okay, looks like all of the test cases have passed. Um, so before we wrap up, here are a few pitfalls to watch out for. We should always remember to handle the edge cases where one list is empty. We need to make sure we are updating our current pointer properly and not attaching the remaining nodes after the loop. And the space and time complexity for this is going to be O of 1 for the space complexity, O of m plus n for the time complexity, where m and n are nothing but the length of list 1 and list 2, the nodes in them. All right, that's a wrap on the merge to sorted list problem on LeetCode. I hope the explanation was good and you found this helpful. Don't forget to hit the like and subscribe button, and let me know if you need any specific video. I'll get that posted. Um, if you have any questions or any further ideas about the video, drop them in the comments below. Thank you for watching, and I'll see you in the next one.